1.3 Applications and Solving Right Triangles. So, trigonometry is used all over the place. It really is. And it's, sorry while I mess around here for a moment. It's a very useful part of our mathematics. It used to be used predominantly to measure indirectly for large distances. So we've done a couple of examples where we try to find the radius of the moon or the distance to the moon and things like that. It's sort of hard to measure. And nowadays it's almost used in any scientific field that you can imagine. So engineering, physics, astronomy, surveying, and the list goes on. So we'll just get a quick sniff of it in this part of the year. You'll see more of this when you do pre-calc, and I do want to give you a heads up that some of these problems that you'll be doing in the problem sets they're challenging. So I hope you work hard at this stuff and look at the solutions and work your way through it. So anyway, let's look at a couple of word problems. Normally the sketches aren't given to you, so I'll try to refer to the sketches, and usually you would come up with those on your own. So a person stands 150 feet away from a flagpole. So here's the person, there's 150 feet. And the angle of elevation, so the angle of elevation is the angle that you would measure if you go parallel to the ground and up to the top of the flagpole. So the angle of elevation is from here to here. And assume that the person's eyes are a vertical distance of 6 feet from the ground. So the eyes are actually 6 feet from the ground. So this was a given and this was a given. And we want to know the height of the flagpole. Well, let's see what we have. We have an angle, we have an opposite side, and we have an adjacent side. So with this angle, I could make opposite over adjacent is a tangent, right? So the tangent of 32 degrees is the height divided by the 150. So think of this as over 1. So we're going to cross multiply, so that means that the height will be 150 times the tangent of 32 degrees. Okay. You'll need to use a calculator on this. Make sure that you are in degrees, and when you do this, you will get 93.7 feet. Now don't think that you're completely done yet, because the 93.7 feet is the distance from here to here. So you need to add those two together to get the height of the full pole. So 99.7 feet for the flagpole. So the flagpole is 99.7 feet. So very straightforward problem, okay? I promise you they'll get a little bit harder. For example, on this one, a person standing 400 feet from the base of the mountain measures the angle of elevation. So going up from the ground to the top of the mountain to be 25 degrees. So right now, this is the picture that we have. Okay, so there's the mountain, 25 degrees up. Then the person walks 500 feet back. So the distance from here to here is another 500. So we used to be 400 feet away. Now we are 500 feet away from that, or 900 feet away. And when you are 900 feet away, it's 20 degrees to the top of the mountain. Now keep in mind that mountains usually have their highest point somewhere in the middle of the mountain, okay, not in a spot that you can just look straight up and measure, for example. So there's an unknown distance here that is related to the height of the actual mountain, and that's why we have a little X here. And that's really what makes this a particularly challenging problem. So based on that, again, we have opposites over adjacents. We know that the tangent of 25 degrees is the height divided by the 400 plus x. And then we also know that the tangent of 20 degrees is going to be equal to that same height, and then now divided by 900 plus x, 500 plus 400. Well, we can solve this for h. Now, different than in the previous example is that in the previous example, when we solved for h, we got 150 times the tangent of 32 degrees. Well, that's something we can put in the calculator. Here, when you put this over 1, we get that the height is equal to the tangent of 25 degrees times 400 plus x, and that unknown x there, this is what's making this problem challenging. I said that a moment ago. So the same thing over here. It would be then the tangent of 20 degrees, and then we get 900 plus x. And then since h is worth that much here and there, that means that the tangent of 25 degrees times 400 plus x must be equal to the tangent of 20 degrees times 900 plus x. And now we have an equation with only one variable. Now it happens to be on both sides, so I'm going to have to work my way through this. So distribute, so x times tangent of 25, and then plus 400 times the tangent of 25. And on this side we would get x times the tangent of 20 degrees, and then 900 times the tangent of 20 degrees. Now, I'm not going to write down what 900 times the tangent of 20 is because I want my answer to be as accurate as possible. So I'm going to manipulate stuff back and forth so that I get all my x's over here. So I need to subtract this one. So that cancels. And that means that on this side I will get x times the tangent of 25 degrees minus x times the tangent of 20 degrees. And then here I will want to do the same thing, but now I'm going to subtract 400 times the tangent of 25 degrees on this side to cancel that part. But that means that I also need to write minus, oh sorry, ahead of myself, 900 tangent of 20 degrees minus 400 times the tangent of 25. Well, two steps left. The next step is a little tricky. X is common, right? So if I take the x out, that leaves you the tangent of 25 degrees minus the x was taken out minus the tangent of 20 degrees equals 900 times the tangent of 20 degrees minus 400 times the tangent of 25 degrees. And so now I can divide by the tangent of 25 degrees minus the tangent of 20 degrees. Now on your calculator, this is important when you put this in the top in brackets, then divide by, and then divide by this thing in brackets. And when you do that, and this is something that you guys need to check, you get the following answer for x, right? We get x equals 1,378.3 feet. Okay, so that's this part. So that drawing isn't very accurate, right? Skill-wise, because this x is bigger than that. Okay, well that doesn't answer the question actually, because I wanted to know the height. So take this x and put it in either one of these two. So you have a height here and a height there. So it doesn't matter which one you use. So we're going to use the first one, tangent of 25 degrees times 400 plus 1,378.3, and when you do this you'll get a height of 829 feet. Decent sized mountain. Okay. Alright, another one. A blimp 4,280 feet above the ground measures an angle of depression. So depression is going from the horizontal line down, D for down, and this angle is 24 degrees. Assuming the ground is flat, so assuming that there really is a parallel line here, how far away along the ground is the house from the blimp? So we want to know the distance from here to here. Well, if these two lines are parallel, so if this line is parallel to that line, then these angles must be the same. So theta is also 24 degrees. And then that gives you an opposite over adjacent, so we know that the tangent of 24 degrees is opposite 4,280 divided by the x. Think of this as over 1, so you cross multiply, or really just, actually we're going to switch spots here. So that distance is 4,280 divided by the tangent of 24 degrees, and that gives you an answer of, turn my page, 9,613 feet. Okay, So a fairly straightforward problem again. Need to make sure that we cover some vocabulary here as well. So depression is the angle down from the horizontal, and we saw the elevation is the angle up from the horizontal line. Okay? Alright. One more problem. So this one's a little more difficult. Not too bad. So we're going to try to estimate the radius of the Earth, and this is what I meant with indirect measurement. So I guess I was ahead of myself. We didn't do that yet. So we're going to indirectly measure the radius of the Earth by using trigonometry. So an observer at the top of a mountain 3 miles above sea level. So we're here, or here we are on the Earth, and we are exactly 3 miles above it. Measures an angle of depression of 2.23 degrees. So you're looking horizontally, and when you look horizontal, when you go 2.23 degrees down, that's when you could draw a line from your eyes to the horizon. And we should be able to use this picture to come up with an estimate for R. So let's see. And I find that this picture that the book uses, this angle is way too big. That's clearly not 2.23, so it should be much, much closer here. And that would have helped a little bit, but we know the following. We know that the angle here at A, we know that this angle here must be 90, because we are directly above, okay? And we know that if you are directly above, and then if you look straight ahead, that you are at a 90-degree angle. So that's 90. So if that angle is 90, then let's call this alpha, alpha being the little angle here. Then we know that alpha is 90 degrees minus the 2.23. So that is 90 minus 2 is 88, so it's 87.77 degrees. Okay, so that gives me alpha. If you're looking at the horizon, then your line of sight, so this is your line of sight, is going to be touching or tangent to the Earth, where the horizon and your line of sight meets. And again, Thales' theorem says then that this is another 90-degree angle. So if that's 90, and this one is known, then we know what theta is. We know that theta is that 180 minus the right angle from Thales' theorem, and then minus the 87.77 that I just figured out above here. And when you do that, you get 2.23 again. Right? 180 minus 90 gives you 90 again, and 90 minus 87.77 should give you this one back. So that one is now known. Okay? Alright, so now let's look at what else do we have. So we have an angle here. We have a radius, we have a right angle here, and we have a radius and 3 here. So the two sides that are relative to the angle I'm in here right now are the adjacent side and the hypotenuse over here, and that would be a cosine. So the cosine of theta is the radius divided by the radius plus 3. Well, it doesn't seem to help too much. I can fill this part in though. I can at least write the cosine of 2.23 degrees is equal to r divided by r plus 3, and that is an equation with only one variable. It's just that I have the same variable in 2 spots. So let's see what happens if you cross multiply. So I'm going to cross multiply here. So we're going to do r plus 3 times the cosine of 2.23 degrees is equal to r. Distribute. So r times the cosine of 2.23 degrees plus 3 times the cosine of 2.23 degrees is equal to r. Let's bring this thing over here. So by subtracting it, right, I'm going to do minus r cosine 2.23. So then I would just get 3 cosine 2.23 degrees is equal to r minus r cosine 2.23. And then we get that same trick again that we just saw earlier, 2 problems ago. R is common, so when you take it out, r divided by r is 1, so I don't really make it disappear, but I'm sort of doing the opposite of distributing, right? So I'm factoring, and r taken out, so that leaves cosine 2, 3. And here I get 3 cosine 2.23 degrees. So that means that r is this thing divided by 1 minus the cosine of 2.23 degrees. And that would be, I have an answer here somewhere, 3,958.3 miles. So that is my final answer. And that's it. Thank you.